Okay, should be live. Get the chats up and welcome back, everyone. So today I'm going to be working on the SMC driver for Apple Silicon Macs on Linux. Also, hopefully the audio is fine. I was messing with the microphone level a bit earlier, and hopefully I didn't mess up the gain staging. So, yeah. So I'm going to be working on the SMC driver, and the SMC is a thing that Apple's Macs have had for forever, basically. I think it means system management controller or something like that. And on Apple Silicon Macs, it's done differently though. Basically, it's in charge of things like temperatures and fan control. People know this. If you're a Mac user, you've probably used SMC fan control type stuff and all that. But Linux has a driver for the old SMC on Intel Macs. But it's kind of a, actually, let me show you what it looks like. Also, I should probably be working on this branch. And I should probably rebase this, but I don't think this driver is going to change much, so I can do that later. Yeah, so this is the old driver. And it's 1,400 lines of code in one file that is implementing a few things like motion sensors, which aren't applicable to the Apple Silicon Macs. I think the light sensor is also not applicable, and the key backlight is done in a different way. So, like, the idea is the same as the old Apple SMCs, but what actually ends up wait, Apple backlight default trigger NAND disk? What? Wait, what? Are they defaulting the keyboard backlight to be triggered by disk access? Okay, that I have no idea what that's about. But yeah, okay. So yeah, this tries to do everything in one file, and it matches by DMI IDs, which is another problem. And this doesn't work on T2 Macs because they use a different interface. It actually hangs and goes crazy. So like, there's a bunch of problems with this driver, and most of it is not actually useful for M1 Macs. I think the main things we share with M1 Macs are the fan and temperature controls, and that's mostly it. And the general approach of the SMC stuff, but the interface to the SMC is completely different on M1 Macs. So instead of trying to refactor this into a driver that works for us, it makes more sense to just make a new driver from scratch. And I'm going to make it more modular so that we can have different backends, and one will be the one that is used on M1 Macs, but then we can have another one for T2 Macs and one for the older Macs. And so if that ends up becoming more of a clean driver, then that would also be a good candidate for obsoleting this this driver and replacing it with that one, even on older x86 Macs. So we'll see if that happens. But for now, I want to just get started on the new driver. So the main thing is that SMC on the M1 Macs, I actually have some code to talk to it already in Mini. So this is similar to 2 days ago, where I already have the prototype and I just need to to write the real driver. But in this case, it's Linux, not Mini. So I have the SMC client here, and it's a very, very simple protocol. There's no IOMMU. There's no. It only uses shared memory on like a limited SRAM that it has. So it doesn't even have. SMC does not have access to main RAM, unlike other coprocessors, which do via IOMMU. So SMC just has this little tiny shared memory that is dedicated to it, and basically you just read and write keys, and the data can be inline in the 64-bit message if it fits. Why is Firefox doing this again? I thought it's supposed to... Hold on. Obviously, I don't want like notifications going through. Yeah, wasn't there a use system backend or something like that was supposed to be? Hold on. how was I like Firefox used to send notifications through the Linux system notification thing, which is muted now because I'm streaming. And then there was something that made it stop doing that, and now it's doing it again. Desktop. Hold on. There was some way of making it use the system notifications. I remember I found the config key at some point, and then like yeah, it's like, did they remove support for that? And I think I remember the name was something like that was hard to find. It's gonna be annoying. No. That is so annoying. And that was a thing to disable notifications until the next boot, and that also, I think, went away. Oh, okay, so it does have that. Okay, let's just go with that for now, and I'll figure out the how to make this use the system notifications in the future. Firefox, why do you do this to me? Okay. So, sorry about that. So, I was saying that this just has a thing where it can it uses a very simple protocol on top of the existing coprocessor stuff that is shared by all the coprocessors on the M1. So Linux already has support for that because Sven wrote it to make the NVMe coprocessor work and boot. So I'm going to be building on top of that. And then on top of that, there's a very simple interface, which is what you see here. It basically just has read key, write key messages, and you can get key info, initialize, and the keys can be inline if they're 32 bits or less for reads, and they always are inline for writes, I think. Sorry, no, writes are always in shared memory. Reads can be inline. And if they're more than 4 bytes, then they have to be out of shared memory. And then there's a get key info message, which returns. Actually, I think that one's not actually implemented here. I think I just have it in the tracer, but not in the client. But that one returns a structure in shared memory that has like the type and some other things. And that's pretty much it. So it's a very simple thing. And it does support having multiple IDs outstanding at the same time, but it's yeah. We're probably just gonna have a big mutex around it because I don't think we're gonna need to worry too much about that. So let's see how that goes. So this is the old driver. Now, one of the yes, use alerts instead of notifications. Thank you. I knew it was like it didn't have notifications in there. But it's set to true. It's set to true. So why is it doing that? I maybe it's because it's muted at the system, and so it's, I don't know. Or maybe it doesn't work in this Firefox version or something. Okay. Anyway, I disabled it for now. So, as I was saying, the one of the questions is, where should this driver live? Because if we think of it as a SOC thing for Apple Silicon, then SOC Apple makes sense. Okay, what is up with these like random like spam messages with random letter codes. Like, is this some kind of bot system using YouTube channels to communicate or something, or what? I keep seeing that like all the time. So yeah, where should this driver live? If it's an Apple thing, then you would expect it to live like for SOC to be under SOC Apple. It makes sense, and that's already where we have RTKit, which is the this one because it changed a bit. Oh, and we have a crash log file now. So this is the core code that we're going to be building on top of. But if this is going to have backends for x86 and T2 Max in the future, then it doesn't make any sense here. So the question is where? The old one lives in hardware mon. That's no longer accurate. SMC does a lot more things than hardware monitoring, so it definitely shouldn't live there. Now, it's kind of a multifunction device, but it's a weird multifunction device in that the backend is, RTKit. So what, maybe it makes sense here, but it feels a bit weird because it's not your typical SMC. It could be a platform device. But then, those are like under x86 and stuff like that. But maybe it makes sense here. Maybe if I just make an Apple directory here, because it does feel like it's sort of morally speaking, the kind of thing you would find in platform devices here. Like it's like OPC EC. It's basically an embedded controller for our purposes. So maybe it makes sense to make an Apple directory here. Instead of Apple SMC, you need a new driver name so as to not conflict with the older one, which is going to be a bit annoying. But what should I call that? I'll have to figure something out. But yeah, I think driver's platform is probably where this should live. And then it will have backends, and one of them will end up backending through the Socket Apple stuff. At least that's my current guess. But not that moving the driver is particularly hard anyway. So I think I'm going to start off by doing it here. So let's make an Apple directory here. And what do we call that? What's the Kconfig in there? Let me close some of this or minimize some of this. Oh, it sources everything. Because it would basically be eventually config x86. Because Arch Apple is an ARM64 thing. So maybe I can just make it unconditional. Is this sorted by anything? MOG? No, it's not sorted by anything. Well, fine. Yeah, so maybe this can just be unconditional at this level, and then the Kconfig will do the right thing. Because where is this defined? That's interesting. Yeah, driverless platform. Oh, okay, no, it's just in the subdriver. Okay, then in that case, it can just be config Apple platforms. And then the sub Kconfig file. And minimize this. Actually, let me send this to another desktop. So let me open up. Just open up the Surface stuff. Just think. Whoa! Oh yeah, that problem. So that's an interesting bug. If you end up with like a directory in the in the Kate command line, it opens in a new window for some reason. I don't know why. I should file a bug for that so it doesn't do that. I was very confused last time when I saw that. Okay, let's get the make files and do a bit of copy paste here. So get a bit of all right. So the Apple SMC one is called is called what? Oh, there's sorry. Hold on. Yes, sensors Apple SMC. So depends on Arch Apple. For now, this one will depend on Arch Apple. But then eventually this will probably also say x86. And then we also need the RTKit stuff. So that'll come from here. Actually, we can get compile test on that. And it's defaulted on Arch Apple. How much is known about SMC? Do I know when to turn on the fan because it's battery percent? Well, those things, the fans are the same as on the old SMC, I think. And the battery, I think someone already worked that out on OpenBSD. But basically, it's a key value store, and we can list all the keys. So it's actually pretty obvious to just dump everything and see, what's in there. Probably while I'm developing this, I will also mess with the mini driver and add a couple test scripts to dump everything and just investigate a bit. So that's why I'm kind of jumping straight into writing the Linux driver, because I already kind of know what to expect. And the details I can sort of work out while I write the Linux code. So, Apple SMC driver. Yeah, so for now, we depend on Arch Apple or compile test. And Arch Apple, if I remember correctly, is an ARM thing. Yes. So this will depend on ARM right now, but eventually we can make this work on x86, and then it will conflict with the hardware mon Apple SMC driver. Yeah, like there's that was in the it's in here, I think. Yeah, there's a number key, right? So you can get the key count, and then there's a request for getting like next key or something like that. So you can just list them that way. See, like read command, write command, get key by index, get key by it type command. Actually, do those commands even match the? It'd be really funny if they even kept those command numbers. Let me check mini SMC. Where is that? Oh, they do. Cool. So they even kept the command numbers from the old SMC. Except we have a few things now. We have a notification and some kind of payload thing. So yeah, you can just get it by index, which I think I don't support yet, but should be able to do that. Yeah, yeah. Some Apple does some things in a nice way, and then does some other things in an insane way. It's pretty hit and miss with Apple. But yeah. Actually, I wonder if the commands have any kind of probably not. Wait, status. The API is actually similar in any way. Sends a byte, send commands in argument. Nah, this is different. Yeah, at that level it's different. So even though the command numbers might be the same, that doesn't actually it's not very useful to share. So probably want some of that. And let's see. Where was I? Platform, Apple, Kconfig. Yeah. So in here. What was that called? Sensors. The module will be called. What are we going to call this one? Not SMC. Nah. Okay, and then how do I nest these things in here? Like submenu or something? I'm forgetting how the Kconfig stuff works. Is it just spaces, or how does that usually work? The thing is, it's not going to be Apple ARM SMC because I'm going to make backends for this, right? So we're going to have like a Mac SMC module, and then on top of that, it'll be like Mac SMC ARM or like Mac SMC ASC and Mac SMC x86 and stuff, right? So that's why I don't want this top level module to be specific to Apple Silicon Macs. It's just that right now only it supports Apple Silicon Macs. Oh, it's menu? Is that what it is? No, that's just that's an actual menu. That's not what I want though. I want the like indentation thing. How does that work in these things? In that case, that one wouldn't depend on RTKit. This one would depend on RTKit. And then eventually, I'm also thinking that I will actually want to have not just the not necessarily just the actually not sure. About the SMC like subdrivers, because I want to split this off into different drivers for the different features that SMC provides. The thing is, it's not specific to the M1, right? The older chips also have it, newer ones will have it, and like the Apple Silicon, differentiator is RTKit. But because I eventually want this to have backends for T2 Max and x86 Max, then that's not specific, right? Let's try that anyway, and get a mini config on there. Device drivers, platform. Oh yeah, it does. Okay, so it does nest automatically. I don't actually need to do anything. Cool. In that case, I don't really need that. Wait, why did that become... Hold on. Huh? Oh, because it was a search result? Okay. Okay, cool. Yeah, that should work. Then when it gets into a subdirectory... Probably. Nah. Anyway, I can always move things later if... how is this organized for the other one? Surface has that aggregator thing. x86 has a Dell subdirectory, but then Chrome has the cross EC thing or like that. Yeah, I think we can do it like this for now. Okay, something like that. So let's see how I. There's already a Rust crate called Mac SMC in case you want to avoid overloading. Well, I mean, I think in kernel land we can afford to have name collisions with something like that. But anyway, the bike setting the module name is something that we can always do later. So now NVMe. In this case, by the way, the RTKit stuff, if I remember correctly, is or MIT. So we're gonna do it like that. And same for all these actually. Well, we don't really care about Kconfig actually. It's kind of pointless. Yeah, the Kconfig files can be GPL only. Nobody cares about those. But the core I definitely want to be GPL or MIT because that's a new driver, and RTKit should be or MIT. Yes. You actually need the copyright symbol there. Because it's not 2017 plus. Like, eventually I want this to be the driver for all Apple SMCs, and then Apple SMC can just go away. But you know, for a while we're gonna have two drivers, so Oh, why is that module license? Oh, because that was the GPL one, yeah. So we need that one like that. And we could use a description on here. Okay. Let me also get this set to kernel. So that's gonna fail in some stuff. Let's let it build. So, more things that we need to get from NVMe. Okay, this is really slow when I'm running a build. So there's not much I can copy from here other than just to get an idea of how to initialize RTKit. So I can afford the license change for that. This is really slowing down with my with this build. Hold on, maybe it should be offloading to. We did with a J10, so it's not that bad. Actually, let me just nice it. Yeah, I use this CC and Ccache, and so it'll be a lot faster for rebuilds and stuff. But because I did a rebase and I changed some stuff and whatever, it's slow this time around. Okay. Whoa! Did Kate just crash? Is that a thing? Is that a thing that happens? That's the first time I've seen Kate crash on me. That okay. I don't think so. No, I've got plenty of RAM. RTKit here or sock? Sock apple RTKit, yes. That's what I want. These are the functions I've got to use. And I need to implement this. So there's going to be something interesting here with the shared memory stuff, because in this case, the shared memory buffers are owned by RTKit because they're in shared they're in that special SRAM, but that's also different from how NVMe does it. So I'm not sure how that works. So I might change this a bit, but for now, I'm not sure if we need .crashed. How does NVMe do it? Where is NVMe? Yeah, so I definitely need that in here. So let's just call into the Dart. It does owner Linux, yeah. So it should be owner SMC. Those are just going to be pass-throughs, basically, just IO map and remap. Actually, is this even used anywhere? I don't think so. Although there was a test SMC driver somewhere, I think that's been had and I forgot. But it's all probably changed anyway, because he did a bunch of changes to the RTKit stuff. So let's see. And actually, these functions, what they should actually do is whitelist. They should actually check whether the shared memory address is what we expect, because otherwise the coprocessor could be, compromising the system. So that's a good thing to do there. It's basically a no-op, except for that. Actually, it should be like fysmem. Were those IOMEM pointers supposed to be... There's a book there. Okay, yes, that was a return. So now what I want is what was the right thing for that? Map. It's fis resource size T. Really? Is that the right thing for fis address? Hold on, I'm just... It's fis address T, right? Yeah, that makes more sense. All right, let's make a device tree entry for this already, since we're going to need that eventually. 64 boot DTS Apple. I will test this initially on my Mac Mini, I guess. It will be a little bit easier than on the T6000, and then we'll see if it works on a T6000. So in that case, T8103 is where I want. And let's look at the Apple device tree and copy pasta. Not copy pasta, we have to redo it anyway, but I think this is the shared memory, and then these are the and those are the Actually, that my SMC thing will tell me that. Where was the mini experiments? CA enabled devices. Oh no, apparently it was 0. Okay. So this is the... Oh, is the SRAM only one page? Hold on. SMC.py. It gets the shared memory from the first message, but what was that? Let me just run it and see what happens. Experiments, PCI enabled devices, that'll do it. That 23 FE 5000. 2. Oh yeah, because the 2 gets set at 3 FE though. 3 FE. It's weird. Oh, is that it? Yeah, that's it. Okay. 23 FE 0000. Yeah. How long is it? This. Okay. So we'll have a 1 megabyte SRAM. That's what it is. Yeah. So we will define that as a reg, and that will be the SMC memory. And that will be basically whitelisted. Cool. And that's 23 FE, so a bit before this. 3 FE somewhere here. Yeah, makes sense. It's after pin control SMC. I think that's the only thing I need. I'm not sure if it's C00 or what. I think it's just that, though. Well, ANS claims to be only 4,000, but it has the CPU start registers in there, doesn't it? Weren't those at offset 4,000? Oh, no, because the M box is separate. Yeah, that's why. And this would be... we need an interrupt for that. No, wait, the interrupt would be the M-box one only, I think. Do we need a power domain for this? I don't think we have one. Because SMC should always be active anyway. Yeah, I don't think we have a power domain for this. I don't think we have a reset either. Besides, if SMC crashes, by the way, the whole system reboots anyway. So, on inbox. Yeah, 8,000 for RTKit, and that was the same thing for that I fixed there, right? In ASC, sorry, in source ASC, which is not open yet. 8,000, yeah. So I'm not sure where the old 4,000 there came from, and that could be a mistake. That was a thing a couple days ago that I ran into. Apple, where was I? So basically we take that. Also, these are wrong. These go before pin control, 3E4. Yeah. And then we need the interrupts, which should be the same as the ADT, except in order. So I think they're out of order there. Yeah, I think these are just sorted. No power domain for that. Maybe. Does this have a power domain defined, actually? No clock IDs, no power gates. Yeah, no, it doesn't. SMC is not going to have an interrupt because it just goes to the mailbox. Okay. Let me do another make there, see what broke. Missing separator in the Makefile? Okay. So that should instantiate it, hopefully. So probably use the resource T thing here. Yeah, because I want to do it like that. Let me look at the devim. Let me look at this stuff. Actually, let me leave this here for running tests. So I want to keep the region around and then use that to validate the offsets. And I probably just want to remap the entire SRAM on startup and then just have the RTKit stuff return addresses inside that. It'll probably be easier. So in that case, yeah, that. Yeah, structured resource is what I need. Let's go to SRAM base. So in that case, basically these functions will just be a whitelist. So NVMe, I need the RTKit ops for that. Is there really a kernel function for something about resources containing other like address ranges or something? There might be. Resource contains And let's start adding some useful includes. I need RTKit that was where. Need some platform stuff. Let me just steal some from here. Definitely need IO. I do not like that is IO port.h. I'm going to need OF and OF platform almost certainly. Something like that. Okay, so you can just define it like that. So let's do it like this then. There's gonna be more stuff in here though. There's gonna be more bits, like the non-posted stuff. So let's just do. What was the print key thing? PAD. Actually, I want the struct resource stuff, which was what? PA. What's the P? What's the P for? Oh, I can just print the struct resource. Cool. Does that check for returns properly on that? Hopefully, where was I? RTKit, RTKit. It does not. So it shouldn't be enomem, really. Not buffer and not buffer iomem. Hmm. Does this one return pointer errors or? No, it just returns null. Okay, so that's fine then. What was the converse of that? I forget this one. Error pointer, yeah, that. And I want to call that. I want to call that. Enval. Eperm. Not sure. Eperm maybe. What's the one used for syscalls? There was a thing. Default. I think that makes sense. Why doesn't map return? No, it's just void. Cookie, iom pointer, adder, len. Yeah, that one's just a no-op, really. To be honest, I should just have a. Yeah, just do that, and then we can just not have that. Okay, something like that should work. And then just return okay, that should actually just initialize RTKit for us. And it's using devm, so it should even deinitialize it properly when it quits. Let's see if that initializes. Is the Apple Silicon SMC the always-on processor? No, that is a different processor that is not actually always on. The SMC really is always on, I think. Actually, I'm not sure, but it's definitely always on when the system is booted. The always-on processor is always on in the sense that it's on when the system is sleeping, which is a different story. So the SMC is in charge of like battery charging and the like. So I think that one really is actually more always on than the always on processor. Funny enough. I'm not 100% sure how it gets booted though. Like from dead battery conditions and things like that, because it still needs firmware anyway. I mentioned that Apple's naming is a little bit weird sometimes. Okay, how did I get? Hold on, not sock Apple. To get this one here. Oh yes, I had some junk there. Oh. Yeah, AOP isn't actually always on. In fact, it's off when we boot Linux, so we have to boot AOP, and then, it'll be always on. Before start token. Oh, it's that's just a tag. Okay, and we need a receive message call, and these ops need to be below. And the receive call, which is be a note for now. Dev. We want that in there. Do we need a remove call? That actually no, it's devm, so it shouldn't even need the remove for anything. At least right now. For entry for SMC we will, but We don't need shutdown, do we? That's the actual shutdown thing, isn't it? Apparently we do need to call a shutdown here. It's not devim. Okay. I don't think we need a shutdown call. And also, this is kind of the wrong call because SMT never actually shuts down. What we do is we put it into like suspend mode or something. The one I use for SMC is I was doing that here. SMC.stop, and SMC.stop will do. It's just the default, and the default right now is doing management stop, which is kind of the wrong thing to do, but management stop. I need to fix this because this is actually wrong the way it's defined here. This instance starts syslog. It's about power modes. Since 10, yeah, that's what I thought. So, and the RTKit one right now is sending what calls? Actually, yes, Sven added some of these things properly to the mini driver. So let me look at that. The RTKit stuff here has it as the next one is so we do awake. Hibernate. Yeah, so quiesce is the one we need actually. So we need Apple RTKit. Hibernate actually. Hey, okay, it compiles. Let's see what happens. Something like that. Init ramfs, yes. Mimaco, that should actually work. Let's see what happens. Okay. It looks probed. Yeah, that looks probed. Did anything fail? I don't think so. I think we just have no logs for that, but yeah, I think that actually worked. Let me just do Diff info, does that supposed to have a new line? Yes. Wondering if you're still run Gentoo? Yes, this is Gentoo. Yeah. Okay. So this actually worked on the first try. Cool. I'm kind of surprised about that, but okay. 1 second, go to the toilet, and then we start talking to the SMC. Okay. So. Cool. That's actually a small amount of code, and then it's basically going to be just making a little structure for defining like SMC operations, and yeah, that's like it'll make for a pretty small file here, and then the core will have the rest of it. So I think that makes sense as to how to structure these drivers. So a bit of copy pasta for this stuff. So we need some ops for this. And basically the ops that we need are read key, write key, what I have here. How will, somewhat tangentially related, how will Linux support the DCP of the long term given the firmware instability? No, we're just going to bless certain versions, but that's okay because those versions are the versions of DCP firmware that we will choose to install Linux with. It doesn't mean people can't use other macOS versions. It doesn't mean they can't update macOS. So yeah, we'll just pick versions that we think are useful and support them. And that's fine. It's not going to restrict people in what they can do with macOS or other installs. And the DTP driver will just have a bunch of structures for different firmware versions with a specific ABI. Why Apple decided to cut the driver in half instead of doing the more sane thing? I don't know. It's Apple. Sometimes they do insane things. So SMC coprocessors are different than M1 Max. The SMC is built into the M1, so yes. But again, with the way I'm doing this is designed so that we can plug in a backend for T2 Max, which also use a different type of SMC comms, and for x86 Max, and then eventually obsolete the old monolithic Apple SMC driver, hopefully. So, so for read key, we're gonna need key and size only, I think. Basically, yeah. Is there a blog update coming? Yes. Probably in the next few days. I've been thinking about that. I don't actually know what gate key by index does. Because I haven't implemented that. What exactly it's supposed to return. Does it return the value or does it return the... Probably just returns the key, the actual key. I should try that. I don't think macOS uses that. Let me do a quick test and see how that works. We have this thing. So let's make a guess as to how that works. Let's see if that's the index. I think that read something. Yeah, I think that worked. Yeah, cool. So this is value, and then we get the key from that. Yeah, that seems like it worked. But I think the byte order is reversed here. Really? I think the byte order is backwards. Yeah. Really? Is the byte order really different than requests and replies? Oh, okay, that is all kinds of messed up. Okay, I can not do that. And let's not set it to verbose. Where's that coming from? Okay, there we go. That's all the keys. So we have 917 keys. How about that? And then we got an error because I guess the key count is wrong. Okay, that key count is also in the wrong Indian apparently, which is a bit annoying. Yeah, that's right. That really is wow. How'd they manage to get like double Indian swaps in there? It's like they take a little Indian value and then stick it big Indian style into a message that is itself expressed in a little Indian system. How'd they manage that? So in that case, what I want is do this a bit differently. Let's return everything as bytes, and then that will be packed in big endian form. And then Okay, now it does the right thing. And then let's do a get key info, because that's going to be useful. So I can make this a thing that will dump everything. Turn off verbose. I remember that used the shared memory. macOS does that. ID is ID, index, not index. Get key info needs a key. Let's just print it for now. Okay, so there's nothing there. That's expected. Just need a result check. Yeah, I'm doing this all the time with the return thing. So let's just do let's abstract this out. And actually, the ID should be done with that. Okay, that looks good. And then we look at shared memory. Yep, there we go. So we have the first byte is length. I don't know what that P is. But yes, it's nice that it has a self-describing thing. So that's probably it has another flag there. Is that 3 anything, or is that just garbage? That C4 stuff looks like flags, and that 3 might just be nonsense. Yeah, that might just be garbage left over in the SRAM. I wonder if that's just another type, like a different identifier for the type. Interesting. So this UA64 has a different like second code or whatever, which I'm not sure what that is. I think that's most of it though. So we can take off that hex dump and then basically size. Interesting. ACF returns an error reading that. UI16. Let's enable verbose. Well, so that didn't actually work. Key B. Oh, because yeah, those are. Okay, seems to work. FP1. What is FP1F? What is CLH? There's a few weird types there. Those floats don't look right. Are those by any chance in the wrong? Well, first of all, there's that. I hope I do that right. But I get the feeling those floats are backwards. Yeah, that looks more like reasonable floats. Especially if you have voltages or something in there. Yeah, those temperatures look real. Okay, so floats are big Indian apparently. And those voltages look reasonable too. And these UNs do not look reasonable, so I think UNs are also big Indian? But number of keys was little Indian, so what? That's a pretty random number. Okay, no, maybe those are in the right Indian, maybe then. That one looks kind of backwards, though. Oh, that one looks sane, though. What is that? CSRB? Is that another key? Or beats? No, it's not. I don't know what that is. Hmm. What's that? Okay, that's the model number. Platform. So CH8 apparently means an actual string. We have more of those. So the same, just in hex. Okay, yeah, that's cute. Actually, don't even decode it. Let's just leave it in bytes. Yeah, that works. No, I'm trying to agree with these, but I wonder what the R ones are. Yes, also this happens, by the way. After too many reboots, it crashes, and I'm not entirely sure why. It looks like 5.4 is something that crashes. Is it the top bit? Does the top bit mean present? It looks like the top bit means present. So that is a flags thing indeed. Okay, one of them failed there. Uh, because some of them error out anyway. So like clock wake and clock U and stuff, and those are, yeah, like timestamps. In what units? Huh? Microseconds, apparently. $400 days? Looks a bit too much. As I was going to say, well, actually, though, if this is the RTC, 400 days sounds about right from when this was manufactured. So that actually kind of makes sense. So if this is the RTC time, or something like it, without the offset, that actually kind of makes sense. Huh. So maybe it initializes itself to the RTC time or something like that? I know I've powered this off since then, but I wonder what's CLSD then. That also looks like a clock. 412. Hmm. Yeah, so clock wake is when obviously when I reset it. I wonder what clock T is. So it's clock boot and clock wake. Yeah, those make sense. Yeah, so like that makes sense. So like 400 days is probably the last time I unplugged it. 112 days, and then 133 days is when it was manufactured, or something like that. So CLBT and CLSD are probably yeah, like when it was powered on. And wake is the last wake up. And U would be the current clock. Okay, let's start writing some of these things down. Did we have a wiki for this yet, by the way? Because I think some people already started looking at this. Yes, we do. How safe is it to fuzz SMC procedure pretty fireworks? I wouldn't fuzz like band speeds. Actually, that JST is making me suspect I know what that is. It might be one of those OS dictionary things or something. I'm not sure though. It's kind of weird the way it's done. Yeah. Let's edit this a little bit. I'm not sure about the byte reversal story with the thing, because at least the clocks are obviously in the right byte order here. So I think that's fine. No, it's not crash escalation. It's actually the message is like MBIQ overflow. So I think what happens is we're not initializing something and not clearing some kind of queue somewhere, and then it overflows. But I'm not sure what it is yet. I have it on my list of things to do. Anyway, this is enough to get some interesting stuff done. And I know how the types and stuff work now. So I probably want to have some sysfs stuff to just dump all the keys. Okay, so that at least tells me what kind of functions I need to define here. I need read key, write key, get key by index. Does any of this already exist in Apple SMC? Probably. Some of it exists, hopefully. Hardware mon? No, it's not open. Or not. Yeah, the structure's the same, by the way. Oh, okay, that means write and read. Okay, that makes sense. smc.py. Okay, so let's see about implementing these ops. So the first thing I need to do, though, is send the initialize message. So let's do that. And the way we do that is with the RTKit operation for that, which should be in here somewhere. What was the endpoint for this? 20. Let's define the crashed function too, because if SMC crashes, the home computer is going to crash. So, might as well do that. I should use completion for this. Okay, complete timeout. What's unsigned long? Oh, it's how much is left? What does RTKit do exactly with the devm? It calls RTKit free, which stops the thread and basically kills everything. So I think we want that. Which means you don't actually need to do anything. So the stop stuff is just about setting the power states. So in that case, I can just return the error probe in here. Okay, and now the message formats. I think that applies to basically all the messages. Okay, so send message. It's just EP message, okay? We'll do that later with the generic SMC call. We're going to need mutex because we're only going to support doing one operation simultaneously. How do I initialize that? Yeah, just mutex init and log, try log, yeah. Let's go mutex. Actually, you know what? No, the mutex is going to be done in the driver, so that way this doesn't have to worry about that. And does the x86 Apple SMC use message IDs? Because if it does, I can move that code out into there too. Let's see. That looks like it doesn't use IDs. Okay, so that will be done in here then. One second, toilet, and I'm also going to get a quick snack that I have upstairs. Okay. Just going to mute this while I eat a little thing in the convenience store that I had upstairs real quick. Okay, should be back. So, yeah, I want to put as much scaffolding as I can in the parent driver, which doesn't exist yet. So let me write some functions for. Well, let's see if it runs so far. If we get to the initialization. Let's see if it builds. Probably won't. Backend. Oh, need to include SMC.h. Okay, so we don't have these yet. That's a void. Completion done. That needs to be that. Not function if is error. Oops, if I put parentheses there. You don't need that anymore. Just need the alive one. Oh, I need to check for alive in here too. Yeah, oh yes. Okay, there we go. That builds. Let's see if I still didn't break anything. Oh. Actually, I should be tracing. Like, I think I have an SMC tracer, or at least a basic one. Where's Apple SMC stuff? Mac SMC RTKit. Yeah, probe failed. Error failed to start endpoint. Okay. Interesting. Why? That's error node 22. Invalid argument. Okay. Let me actually trace this. Does that do the right thing? I think I do. Yeah, it actually has the things. Let's see. Why aren't I using a text editor that reports syntax errors and stuff as I'm writing? Like VS Code or something. It's like the second person to say that in the last 2 days. I don't know. I like Kate. This is like, I don't know. It's a good text editor. I mean, it has more features that I'm just not using yet. That did not actually do anything, which is not good. Oh, is that because it passed it as an arc? Hold on. Still need the enable PCI experiment. I don't, but it shouldn't break anything. It's good for testing. Why am I getting nothing here? Actually, it probably helps if I don't do that experiment, because then it won't load the Wi-Fi driver, and it'll be less spam. Okay, let's debug RTKit. There should be a define for this somewhere. But tracer isn't tracing anything, so I think I must have something really dumb in my... That's wrong, by the way. Oh, Waken boot missing. Okay, but then why did it init? Oh, okay, so boot is the... yeah, you're right. So I need, yes, rtkit.h wake. Indeed. Okay. Whoa, nice. Nice explosion. Okay, so at least we got... yeah, now we got... I was expecting more debug from here. Okay. Ooh, okay. That explains in instantly RTKit map. Did I not load this SRAM basis? Oh, I didn't get the resource. I only error mapped it. I need Well, there is a they get and error map. Oh, but not, is there by name? No. There's IO remap by name, but is there no... Huh. That does platform get resource by name. Okay. Oh yeah, because it doesn't need devm, I guess, in that case. That just returns null, so... I guess enval, EIO maybe. We get the SRAM region there. See if that works. The BPDev. Oh, expect to start device. Okay. Sorry, by name is a pdef. Okay, there we go. Failed to send the init message. Okay, send message returns a positive value apparently. Timed out. Okay, getting somewhere. Let's set that a bit longer, and all right, you look at the message, and then it happens the timeout very quickly, though. Oh, okay, equals 0 is what I want, yeah. Because 0 means nothing left, so it actually timed out. Yeah, makes sense. There we go. Okay, so now it initializes, and I'm going to drop this back to 100 milliseconds for init, which should really be plenty. Okay, so that is the basic init, and now we can start writing the actual. I'm kind of doing this backwards, right? I'm making a backend driver before the core, but in this case it makes sense because the backend has to initialize everything. Apple SMC. All right, let's get this in, and now SMC.h. We have that, the backend ops. Struct dev. Let's see, how do I want to compose this with the backend driver? Basically, on the same struct device, the RTKit stuff is using. It's not using platform data. I don't think we need much of that anyway. Just give it a struct device. Um, yeah, because normally I would use like a containing thing. But do I want to make the structure public for SMC stuff here? Shouldn't be necessary. Yeah, let's just do it like that. Yeah, so we already have the core thing there, so it'll basically SMC. And then we pass a cookie, and then that'll be what yeah, that makes sense. Do I want to pass a cookie on that? Struct Apple SMC. Yeah, then it'll just be cookie here. And that's just a prototype. So then we call that here. And we pass the SMC ops. So probably in this particular case, I want to try hibernating it. If init fails. Apple comma SMC. Yeah, we can call it Apple SMC. I was kind of wondering if we would do that one or ASC, but I guess in device tree platforms, it's always going to be ASC, at least at this point. So sure, we can do that. SMC core. All right, so initialize there. If it's an error, try to hibernate it sort of opportunistically. Um, hmm. So probably if send message fails, this thing is totally messed up. Start endpoint. We might be able to do that. Timeout, I can probably do like this. Okay, so Apple SMC init. And this needs to be exported because it's actually going to be a module. Does that GPL thing make any sense? If this is, it probably doesn't make any sense if the module is or MIT. Yes, I know the SMC init code returns the SRAM address. I'm already doing that here. See, I map it with the message. And it's weird because it's not even the format of the other messages, which is kind of silly. So we need this struct in here. Because the init call returns the address of the buffer inside SRAM that that is used for the SMC stuff. But the device tree has the entire SRAM range, and that is used to validate all the addresses from RTKit, including that return against that. It's basically a security thing. Because there's no IOMMU here, so SMC could tell you the SRAM addresses, somewhere in main RAM. Let's see. Let's call that B for short. I need calling that a lot. Actually, Sven used the cookie nomenclature for the for RTKits. I'm keeping that. I would normally have called it context actually, but whatever. All right. We don't need the key count there. All that's going to come from there. We just need the command done and the message ID. Do we do like does the Linux kernel style allow those things? Like 4-character constants? It's in at least one of no, but that's a comment. And that's Python. And those are false positives. Is there a kernel printf thing for 4CCs? Probably. Now you're making me want to get some cookies at the convenience store. I can't believe there's no like 4CC type thing in here. There's got to be something. Maybe this, but then there's an Indianness issue then. No, not for us, because that's an alternated string. It would have to be a buffer. So this one would work, the escape to buffer thing. So or send 4 PE or whatever. But the problem is that then I have an Indianness issue. I like how everyone is inventing their own 4cc system. Yay. Uh, uh, Even RTKit has it. Yay. Um, hmm. The thing is, integers are just nicer, because then if we have to do like numeric keys or things like that, um, so probably what I want to do is um, actually, what was the Indianness that this was using? It goes to integer by doing from bytes big endian. Yeah, okay. I need parentheses there. What is it with those spam messages? It happens every time. Yeah, something like that should work, hopefully. the formatting there? The syntax highlighting is kind of weird. I'm not sure what's going on there. This returns int for reads. Let's also return int. You know what's going to really suck? The floating point ones. Because the kernel doesn't do floating point. Actually, it should be SMC. Those are actually called usually well, probe and remove, but should I call it probe? Yeah, probably. Okay, let's get some includes here. We might not need IO. We don't need OF. We will need SMC.h. That's backend ops. Parentheses there. Okay. Where is that defined actually? Next device. We should probably also want it here. Okay, getting somewhere. Cast. You don't need the K3, it's devm. So that's fine. Start device. Start device. Okay. So now the key thing is does that work? Probably not. Pretty sure it wants a proper token for that. Or not. Maybe it does work. Yeah, that. Let's call this SMC data, it's fine. Uh, okay, getting somewhere. Constant there. Getting somewhere. SMC read remove for okay. So we need to export those. Actually implement those. This is probe. And now the read function, okay. If anything is using that still, how does that work with the freeing? All the subdrivers should already be unloaded here. I'm just gonna leave it like this. And in here will be the calls to the like subdriver free functions or something like that. I think that makes sense. Yeah. Though this is not a reentrant mutex, is it? I don't think so. Maybe it doesn't. No, I guess the subdriver should just yeah, it's probably fine. Okay, so probe const on that. Yeah, I don't need the free indeed. That's the malloc. So nothing there for now. Would that even some of the probe? Some see the structure. Full offside cooking. Backend. Okay, there we go. And then we just need the read function. So int apple SMC read. Just like this. Actually, a buffer there. Eventually, I might want to cache things here, but for now, this is easy enough. Okay, that builds and it's going to crash horribly because there's no actual read function here. So now we get to implement this. And also in core, I want to actually return that. And that should be a U32, actually. Let's see. HC read and write. Okay, so for commands, just call that send message. Same thing as the Python in this case. Mm, mm. And those aren't. Oh, I got these wrong. Sorry, these are supposed to be these functions. What was the return value encoded? SMC. So ID size value. Result is it's a bit different. 70 is result. ID is in the same place, size is in the same place, value is in the same place. Okay, so basically just I don't know how do the notifications come in. I gotta test that in Python somehow. Because I think they come in with probably with 18 in there. So there's some numbers which are not going to mean command completed. I need to make sure that all makes sense. But I'll look at that in a bit. If you get SMC ID, actually, you know what? Let's print the. Let's print the messages here. You'll get, let's see, these ret. What's the like U64 and stuff there? Okay. Okay, so it's always there for LLX. Actually, the ret result is just. I'm gonna get the NDNS right on this. We're doing the strings as big endian. Yeah, so that is correct then. What was the logic that I used exactly for this? The if the requested size is less than 4, then it returns value. Otherwise, it does a read mem. In this case, the requested size. I think that is correct. Is that going to be right with the NDNS? Our data gets the U32 little endian. That's not correct. It should be byte swapped. Uh, it's not. Yeah. Uh. The thing is, it's not like this is going to run on a big Indian system, so it's the whole thing is a bit confusing. But basically, we have an integer, and I want to store it in B32. So, uh, yeah. So this would basically be something like that. I mean, yeah, that's sub 32, but the thing is, we don't know how hypothetically this would work on a big Indian machine. Let's see how close am I to this compiling. Quite a fan of that. Okay. Let's see if that works. Oh no, I need to actually set the stuff in the completion. Da 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 da. Okay, let's see if that works. Yes, that is correct. And why am I getting a buffer request though? Oh, is that only when there are no waiters? Uh, not yet consumed. Okay, yeah, so that's not needed. Okay, that didn't fail. Didn't print it either though. It's there. Is this because of the debug thing? No, dev info should be printed, shouldn't it? Hmm. Am I like being dumb here? What? Okay. Is it just getting stuck on the completion? Does this ever include T2 macro support? Not right now, but eventually I hope that it can be used on T2s. Because I'm making it generic so it can have multiple backends. Okay, so it's getting stuck there. Oh wait, no, it's just because it's probably returning an error? Yeah. Okay. I hate that PTR file thing. Oh, because it's returning the red size and I'm... Actually, I probably want to just do it like this. Nah, maybe we'll see. Actually, yes, red, and in this case, have the core And then why, when that probe failed, did the RTKit thing not complain? Ah. Oh, it should do that. Oh, because it was positive and then probe returned positive. That's why. Failed to get key count. Okay. Is audio working on M1 Mac? Which one of them? It worked on the Mac Mini. um, and I think the headphones jack should work on all the original M1s, not the Pro and the Max. So it does shut down, probe failed, and also that got stuck apparently, which is also not good. Interesting. I wonder where that failed. Yeah, those are all idles. Interesting. That should not be dying. Why is it dying? Why is it hanging? The SMC driver will work across all M series, hopefully. I mean, most of the drivers we're writing will work across most of the M series. Apple don't change things too often for no reason. And this protocol is simple enough that I hope they don't break backwards compat. Why is this hanging? That's really annoying. Just 1 second. Get some water. Okay. Why is it hanging? Oh, yay, the physical keyboard test request works. Okay, cool. I can use that. Show task states. Okay, there's a deferred probe work happening. Ah, there. Okay. Aha, kthread stop got stuck. This might be an RTKit bug. Okay, so that's waiting for that task, and what's the task doing? Is that in there? Yes, we know there's a hung task. Oh, there we go. It's just in schedule. Ah, there we go. Okay, that works now. Or rather, it doesn't work correctly. And now failed with error. 22 failed to get key count. Why is that failing? What's error no 22? Invalid argument. Okay. Was that the size thing returning? Yeah, I think the size was weird. No, the size is correct. It's 4. Should be SMC size. That returns command. Times 4. Is it like parentheses in here? Not quite. Oh, are doing that running the core? No, it should just return it. Ah, star P here, that's why. Zero keys, that's not correct. um, that's returning there. Why is oh, because hold on. Ah, yes, that's not equal to 4. Thanks. There we go. Okay, now that works. Shouldn't really need that anymore. Cool. Okay, so let's write the write function, which is easy enough. It's basically just this backwards. Not even backwards, actually. Write always uses shared memory, I believe. Yes, it has to. So just making sure that it's the same thing. I think it, yeah, it's just a command with size. Wait, am I not setting size? Oh, I'm not setting size. Okay, that's wrong. It's apparently still works, so that's wrong. I think for writes, the return value doesn't do anything. Yeah, it's just ignored. So we can throw that away too. Okay. Cool. And now just implement these two things. And let's see how that works. I need my header. Not RTKit, SMC.c. Actually, that does fit. In Python, you also can't just leave off parameters. You need to have defaults for them. Key by index. And that one was returning just the key and data, I believe. Yeah. Oh, that one's little endian, though, in the return value. But the command already byte swaps. So that should actually work. I think. Yeah. Actually, yeah, it's just actually index is in the same as the key, yeah. It's basically that. And then get key info. Just the key, actually. I could pack the structure and try to just copy it, but I don't really feel like doing that, so... What was that unaligned thing? It's just the same SMC key thing, the same format. So if we put that on the left, that would be big endian. Yeah. If I... Yeah. None of this is going to be a hot path for anything anyway. Okay, I think that completes the driver, the RTKit backend. Hold on, what? Why did I copy that twice? And where is that defined? In ASM unaligned, apparently. This? Yeah, sure. Okay. So, core. We have read, we have write. Let's add the get key info stuff too. Okay. The Christmas tree thing, by the way, is just some maintainers care about that. Not all of them do. Okay, so I guess it's time to write one of the drivers then. The most important one I need first is GPIO, and that one's going to be extra annoying because they. Actually, wait. I need export symbol these things first. What was I saying? Yeah, I'm gonna see if I can make a GPIO driver for this. So, do I want these drivers to be built into the main driver, or do I want them as modules? Probably just built in. Like, there might be config options for turning things on and off, but it makes sense to be built in. I forget how the module stuff worked in Kconfig. Also, this is wrong. Does this really need a comment? I don't think it needs a comment. Whatever. I'll keep the pattern. Yeah, the thing is, if they're actually drivers in the independent subsystems, then I need to have some kind of probing mechanism, right? Like this becomes some kind of bus or something. So like, how do I set it up so that when you load the module, it like probes into an existing SMC? That all seems like overcomplicating things. So I think it makes more sense to just have everything in here. Let's make a few things. GPIO, hardware mon. Actually, the cooling device stuff and all that is kind of separate, so I think it might need a different framework. Let's just call it button is interesting because that includes the notification stuff. So let's do those two first. I forget how the module stuff worked. I keep forgetting, like the how do I put multiple files in a module? Oh, is it just like the module name and then Y, and then that gets added to that? Yeah, I guess it's just that objects thing, right? Do I want underscores or? It's usually underscores. It's kind of a mess. Hold on, let me check. You're right. I might have some of the swapping wrong. Hold on. There's SMC.py. Oh, you're right. Yeah, that is kind of backwards. Where's the Yeah, so it's the low bytes. Hmm, that's annoying. And now the floats are also little endian in that case. Yeah, one wonders why the freaking number key is in the wrong endianness. Okay, so in that case, it's actually saner. In that case, this is actually just normal. Mm-hmm. Is the key count also backwards in Apple SMC? Yeah, it is. Lovely. Do I want to make these use dashes instead of underscores? I mean, we have plenty of underscore module names too, so there's more of those actually, I would say. Oh no, those all become underscores, right? Yeah, it does show up like that. Okay, cool. Yeah, the module name stuff needs to be like that, right? Does that work? Why is everything rebuilding? That's annoying. Ah, okay, yeah, so it does work like that. Okay. Yeah, that seems to work. So let me look at the MFD stuff because I might want that. Because I do need to define like input devices and other things separately. And not the device tree though. So remember there was a way of getting this. There was a way of doing this. It seemed to recall there was a way of doing the of just using this to create sub devices. Yeah, this would work for having the things in the separate subsystems. Probably. Which might be an argument for having this in the MFD subsystem instead of the platform subsystem, but we can always move it. So in that case, let's see if that actually works as intended. Instead of doing it like this, basically I should be able to okay. MFD core apparently. Why is it doing everything again? Uh, okay, so it's probably Kconfig file updates. Huh. Uh, uh, do I want to fix that? Yes. Mm, so I got just the wrong Linux next for this apparently. Yay. Uh, I think Watchdog is not merged yet, so that should work. Um, actually, these are all the merges, right? Yeah. Um, that hopefully works. Oh, the bits are going to be on the wrong... Yeah. This is based on the wrong thing now. We probably want to base these on 516. No, it would be like 17 RC1. That wouldn't help. Yeah, it needs to be next for now. Yeah, I'm going to draw into that. What was the thing for... Yeah, that's what I need. Erase onto... But... Yeah, that's what I want. Yeah. I think that worked. Yeah, that worked. Cool. Of course. Because that got merged already, yeah. That. This might not work. What was this? Yeah, that is on top of 40. There. Oh, 40 to AC3. Yeah, that works. Yes. Yeah, I thought so. That was on top of that too. I need to fix that. It's it was on one of the maintainer things. And that was on the regular one, yes. Is there a 90? Yes. Okay. Hopefully that fixes the problem. Let's see. Yeah, sure, give me that. Didn't I need that for something? I forget. Well, maybe not. I think it was just Diffie Hellman. Okay, so hopefully that is the last time I had to do a full rebuild. So while that's building, I had an issue with the GPIOs, and I want to see if I can figure out a workaround for it. There was an issue with reading only working the first time or something. What was that called? Oh, it's just there. Okay. Huh. That should stop. Okay, that is reasonable. Huh. The enable thing was doing that to OD. Yeah, that problem. Wait, it returned all of those as that. What? Wait a second. That's just uninitialized data. It's just uninitialized data. But why? Do I have the less than equal wrong here too? No, because the num keys thing was working. SMC, where am I? That's less than or equal for read. Okay. Uh-huh. Okay, so that's cute. It's actually returning it in the message, but it's actually uninitialized data from the shared memory. Oh. No, that does work. Okay. Yep. It's just whatever's in shared memory gets returned in the message, which also means that it probably always writes to shared memory and then just dumps that in the message. So there's no way of reading GPIOs then. It's just broken. Well, at least that explains the weird behavior, but it only works the first time. It doesn't actually work. The problem is that Linux kind of wants to know what state GPIOs are in. Is there really no way of reading that? Or is this just a bug? Yeah, it gets cleared after being returned, which is weird. Whoa, what just happened there? Did one command get stuck? Oh, SMC error. Are we not clearing the outstanding in those cases? Or is that just a bug? I'm not sure what happened there. Anyway, yeah. Huh? What happened to 10? How did it skip one? Uh, oh, that's why. Bug. Oh, that is extra annoying. Ah, it has the command flag. It has the command flag. So maybe there's a read command. That would kind of make sense. Let me try some stuff. Um, so what I was setting for the enable devices was that. There's also lower ones though, lowercase. Is there a DP question mark? Also, Kconfig sounds like error message. Really? Oh yeah, invalid key. So if I do, was that GP uppercase or lowercase? Oh, lowercase. Okay, that's why. Interesting. So that's actually your invalid key thing. Okay. Let me trace SMC again. See if I notice anything interesting in the command it sends. Okay, that's an interesting value for the GP09. What was type 20 again? Read key payload. Oh. Okay, well that explains it. That's what read key payload is for. So you call that function And then I guess rekey payload is the way you get the size is 1631, but there's more than that here. What is this? Hold on. 08. And the interesting thing is that there's size is like actually 2 different bytes here. So this is actually 2316, probably in all of these. Is that used any other time? Yes, it is. Always seems to use 04s. It always seems to use that, like 20. Is that just like the new read function? I mean, I'm still getting some stuff for the regular read. Yeah, input size, output size is what I'm thinking. Okay, let me fix the tracer so it actually shows that. Well, I wonder if it's like a read key that also sends in data somehow. So maybe it's like read write or something like that. Okay, let's do it like this then. No, but that hex thing is what gets written to the key on a normal write. So that uses a normal write transaction, not a read payload transaction. At least for because it says PK write 4, so that's a write transaction, right? What did I just break? Why am I getting infos? Huh? What? How is that info? Oh, hmm? Oh, okay, so it doesn't overwrite it. Let's try that again, and then I need this to. Okay, so about those RPs. Ah, okay. So now this ADC thing gets a payload. Okay, it's interesting. Yeah. So it's a it's a function call, really. Yeah. It's not read payload. It's function call is what it is. And the write works as a function call that does not have a return value, basically. I think. Why was I seeing those before? It's just ADC. Ah, interesting. So it gets like VPs. VP0U. Ah, okay. So this is listing. This is uses ADC number and then ADC question mark to get the names of the keys. Then it gets info for those keys. So it's enumerating keys, which is cool. So that's actually listing it all the ADC channels and what keys they correspond to. And then it tries to read a bunch of stuff that doesn't exist. Yeah, and then so GP is like command and then response. That's why. But then it does actually call them writes when there's no return code expected. So it's basically a read-write call. It's basically like a function call. And it can be mixed with the regular writes if there's nothing expected in return. And so the GP there, you can see it gets, yeah. It gets the value in return when it passes like that for GP08. Okay, so this is actually more like that. And then in that case, sort of the flags for that. Aha, so the ADC one actually fails in that case. How does Apple SMC do that? It says 10 func, but then it doesn't actually do that. It doesn't actually use any of that. $85. I get the feeling this is an address, actually. Here, let me do a full boot. Um, and just save it so I can look things around. Read payload. Oh yeah, I guess I renamed it. Do I have my dev setup anywhere? Create settings, terminal settings, VMs, if any? Not really. It's just ad hoc. There's nothing particularly fancy though. Yeah. That. It's really spamming the SMC. Okay, hopefully that's enough log. Okay, so it's not that many RPs actually. Mostly, yeah, a couple of GPIOs and that AAC stuff. So it's not used that much. And then 6 seems to be read GPIO, I guess. Now, the problem is that I don't know which one is outsized and which one is insize because we got two. Which Mac OS version running through hypervisor? I think this was 12.01. 12.01. I'm guessing which ones are and which one's W there, but Yeah, that definitely works. Just payload 0 seems to do it actually. I don't know whether I don't know what the 6 does. Oh, sorry, the 6 is on the top. That returns an error. Okay. But why is it failing now? Hmm? Oh, sorry. It's like that. Yes. Wait, so 8 gets that, but not 1A apparently. Hmm. Interesting. Hmm. So I guess it's time to do a bit of brute forcing here and look through the SMC GPIOs and see if I break something, which I well might. Actually, some of them were on the ADT. Actually, that's the the thing is, it's a physical GPIO controller anyway, right? Is this just brokering stuff through here? That'd be really silly if it is. Uh, someone's twiddling. Okay. No, they're separate. Interesting. Writing 0 the first time didn't do anything. But writing a 1 and then a 0 did. Oh, and it's back. Uh, that's it. Hmm? Okay, that's interesting. And also, so GPIO 9 seems to be reset for the DB2 HDMI. Oh, is that like do a pulse or something? Ah, that's 1 now, which makes sense. Yeah, on that tweet. Okay, that definitely broke it. Yeah, that looks like it's some kind of like pulse thing. But that still does that. Ah, so maybe that's the function code, and that's like pulse, and then the other thing is the value. That would make sense. I wonder what that 80 is in there. What that changes. Seems to just set it anyway. I'm not sure what the difference is. Okay, so then what about that 6 thing that happened there? It always seems to use 6 for 8 and FA. And FA isn't actually specified anywhere. Is there anything else in the SMC that talks about yeah. Hmm. Hmm. Polarity. Yeah, but would they need that? Is there something where I can check that? Hmm. What's the easiest way of finding that out? Is this when I finally have to take apart a Mac Mini to figure out what's going on here? No, but I wonder, like, where do some of these GPIOs come from anyway? Because, like, GPFA, where'd that come from? Yes, it's resetting that. And there's a simple, like, 010, so it's like a software toggle. There's more than one software toggle, apparently. I wonder what's up with those. Hmm. Yeah, but why would Stockholm have a flipped GPIO? I could look at the schematics. Um, and also, these GPIOs are actually supposedly in the PMU or something, 'cause, according to how that is indicated. Um, so I think this is actually SMC brokering SPMI to the PMU. or something like that. Oh, maybe the top byte is like the SPMI address or something like that. That'd be a weird way of doing it, but the 6, I mean. So 13 is Wi-Fi, which I think was D, so that is correct then. Or not. AM FM? I mean, yes, but it was that one, right? I think AM FM is actually the Wi-Fi. Yeah. So GPOD, so that one has the 8-bit set. And it says that will be T-Power enable. So presumably that is active high. Yeah, because otherwise we'd have an underscore L. So that is active high. GPO9 HDMI reset, yes. That's active low. So that does add up with that being active, yeah, like polarity. I was saying this to 1 though, which seems wrong. That doesn't sound right though. So 8 is USB 3 wake. So that's an input, actually. And maybe that's what the 6 is. Maybe that's setting input mode. I don't know what on earth FA is, though. Was that actually part of the... Ah, okay. So those are GPIO names, that's why. Wait, hold on. USB 3 wake is 8? Hold on, no, it's not. Hmm. And bit 40 and 48. No, okay, those have to be something else. So just even bits. I wonder if there's an offset there or something like that. Ah, so that's the HDMI power. The GPIO 20, yeah, HDMI power. But that's also has the 0 there. So what's the other things it's looking at? The 8 is USB 3 wake. Not that many, really. So Stockholm is on F, which is SE power enable, yes. Let's compare that with the 316. Oh, that's the wrong thing. This says VN. I like that there's a desktop here, implying that there is in fact a desktop with M1 Pro or Max. Same SE on both. Same pin. Connected directly, so that doesn't add up with the polarity idea. Yep, that doesn't really add up. So I wonder what that is then, that flag bit at the top. Maybe it's just a setting. Maybe it's like drive or voltage or something. Because I did notice that there is a different voltages listed here on the GS316. 182S2. Do those line up? So reg on AM/FM says 1V8. SD power is 1V8, so that already doesn't add up. Oh, no, sorry, 1V8 is here. Well, LBT. Okay, so 1V8. 1V8, yeah, that doesn't matter. So those are the same. Those are the same. The same voltage, supposedly. Is that what it is? Open drain? Though this is a different thing, though. This GPIO is this GPIO thing is probably using a different encoding for that field. And it has 6 and 17. Huh? Oh, sorry, 17 does be 16 plus 17, 23. That. Yeah, so that's the 5-volt output for the HDMI, which makes sense. And then there's the DP2 HDMI, which enables that. Hopefully that's. Yes, that's actually a thing I can find. Yeah, it's active high. No, the default isn't connected to anything. Okay. Okay, so it's really not clear what those bits do. It could be a setting of some sort. It doesn't seem to be polarity though. But I think I remember that something didn't work if I did set that on the M1 Pro. So give me a second. Let me try. Let's try getting a trace on the M1 Pro. Oh, yeah, I need a power supply. 1 second. Okay. Only problem is that now it's gonna have to charge before it can boot. Or oh no, these okay. Apparently these can boot immediately with the Apple charger. That's good. Okay. So kill that. So there's also an LCD enable thing here, right? 20, which is 1.4. Will that kill it? Yes, that definitely kills the display. So at least I can see the effect there if I yeah, so that does nothing. That also does nothing. That still kills it. And if I do this, that does nothing. That killed it though. Oh, okay. So yeah, probably well this is the power enable, right? So if I do this, it means pulse it high and then go low, which kills it. Which I can see by doing this. It's low now, right? If I do this, it means pulse it low. But because it's a power enable, there's going to be capacitors and stuff. So a reset like short pulse on the power enable is not actually going to kill the display. Yeah, so if I do that, it means pulse it low. That works fine. I wonder if there's a pulse width somewhere though. Okay, that fails. Okay, so it just doesn't like any bits that there. Interesting. That doesn't like any of those. Oh, that killed it. And it's low. Now it's high. Now it's high. Now it's high. Now it's low. Now it's high. Interesting. Now it's low. Now it's okay. That's weird. Letting me hit event. What? How about not destroying the hardware? Okay, what the hell is that? Is that interrupt enable? Oh, I bet that's interrupt enable. Okay, so this is really setting more things in the config. That explains the 6. That's interrupt enable, is what that is. That killed it. I think one of those is input or something like that. So the 6 gets passed on RP. Not right, it's RP actually. Ooh, okay. So maybe for RP, the top bits are like command or something? Is the lid switch in here somewhere? Lid open one via GPIO 1. That got hit events on 1 and 14. 0 and 14. So 1 seems to be button. Let me reboot that and just see if the lid thing yeah, so now when you get events on 3. Ah. So I definitely enabled an interrupt on there somewhere. So 3 seems to be like lit state. And if I do that, okay, how did I enable that now? Oh, I just broke the lid events. I hope I didn't break it completely. I think I probably set it as an output at that point. Okay, it's still getting events. So how did I enable that interrupt before? I'm doing this apparently, which doesn't work anymore. Oh, not 14. Oh, 1. Still doesn't work. Okay. How did I do that? Okay, that does it. So it's the right 32 that does it. still get hit events doing that. If I write another value, still get hit events doing that. Oh, sorry, that's 14. SLC power enable undumb. GPIO 1. That does work. It still works. So the lid still works there, even though I... Oh, I wonder if... Where is lid open connected? AOP. Okay. So I'm getting the feeling that a write like this writes to the output buffer, which is not necessarily actually active, because right now I can write a 1, and this reads the output buffer. And it's still working. And I can write a 0, and it'll read a 0. But again, it's still working. And then there's another thing that changes the config. So when I broke it, that was probably the input-output select. And that happened when I did what exactly? Where is that? I just missed it. So this write 32 of that always returns the event. So that's some kind of like interrupt clear probably, or something like that. Okay, that does it, yeah. So that bit is making those events work. If I do this, that interesting. So that clears it, obviously. So now it's disabled. I think that bottom thing might be like config or something. Or not. Okay, that's still not doing it. Doesn't do anything there. I feel like the top bits are maybe command or something like that. And like 0 is like control output, and 6 is possibly something with interrupts. So is there a read input command? Aha. Okay, that's starting to make sense. I think the top is command. Suddenly things make sense. Okay. So 3 doesn't exist or doesn't like it. Oh, actually, you know what? Okay, 6 did something. Okay, I see. So this is get set. When you do a write, it does a set. When you do an RW, it does a get. Okay, so that makes sense now. Okay, so if I do read write, read input, command 2, that still works, so I didn't break the mode. Okay, so if I do this 6,000 thing, I get 1, which is what I wrote. Yeah, so that works. So what are the other GPIOs? Are these like interrupt modes or something else? If that is 1, the other is charger aux, okay, that's 0. Reset to 1, interesting. Codec wake L, that kind of makes sense. Okay. 5 is IPD wake L, okay, so those are wake ups. 6 is interesting. Seven is SDCon state change. Okay, so those are all inputs. Interesting. 16 is a no connect. So that actually should be free to play with. So that claims the input is 0. So that has the output buffer, but the input is still off. Okay. So can I read one of the ones that has an actual output, like display power, LCD power enable is 20, so 1, 4. Okay, so the input buffer is not usable. Okay, so let's mess with this one. That killed it. So that also seems to be just setting the pin somehow. That doesn't do anything. 3 also killed it, okay. Three might be like set mode or something. No, that killed it. Okay. Let's see. 3, 1. Oh. Okay. Interesting. I get the feeling that's like set output plus mode. Yeah, that's fine. And 4 fails. Uh, uh, uh. And that can read, actually, apparently. Aha, it is 3. Okay, cool. I think this is get mode. Interesting. And on 1, it doesn't work. Oh, because maybe those are only inputs? Maybe those are hard-coded to be only inputs or something like that? So if I do that for some of the other outputs, like 8. Okay, that doesn't let me do it. Interesting. 1A is 26, SD power enable. Interesting, that's an output. Mm. So maybe that's low bit is yep. Okay, so what about the other inputs? So 4 is supposed to be the input from Wi-Fi. I think that's just the output buffer again. Yeah. Probably 0 is like legacy, and then starting at 1 is the actual commands. So then, how did I get interrupts? I think it was 6. I broke it, apparently. So the interesting thing is that it's like 3 here. So it's like state change interrupt. And it's like old state, new state are the 2 arguments. And then if I set it to 0, nothing happens. The 1, nothing happens. But at the 2, I get a notification on rising edges. I get 3 is falling. And 4 is both. Okay, so that kind of makes sense. Let me see what it defaulted to again. Yeah, it defaults to both. And then we also have 1. Which goes to that gave me a falling, a single falling. Okay, yeah. So the problem is that there's going to be an ACK somewhere to and that's going to be it. Yeah, so now I set the falling. Yep, that's it. 6 RW does work. 5 does not make any sense because it's an ACK. And 4, apparently I cannot read for. Okay. So now the question is, how did I get the other interrupt notifications earlier? Those the ones that had the pin number in them. When did that start happening? Writing to 4, apparently. Which didn't work. Oh, sorry, 01. Oh, because 14 is like the output. Maybe it only works on some pins? Wait, why 14 though? That's 20 LCD. Huh? Oh, that might be an artifact of something gone wrong. No, but 14 was already doing that. And then 3 is... Hmm. Huh. How did that work before? On 7? Okay. That killed the display. That kills it. Even though it's 1. I think that's just unrelated. Like it's getting notifications from that. for every other interrupt. I think it's just an interaction between the interrupt request and the acts and stuff. Yeah. I think like one just triggers the other. So what about one of the NCs, like 25? That one doesn't support interrupts. And what about 4? We're still missing that one. That one works on GPIO 1. That's not working. Okay, that's probably interrupt enable then. I set up your revert macros using bootloader. Supposed to GDB, LDB, KDP remote. No, we don't have a GDB stub. You have the debug features on the hypervisor. That's it. We don't have an actual GDB stub. You have to use a Python shell. Okay. Yep. Okay. So let me try another interrupt, see if it does a similar thing. We should have sdcon state change L GPIO 7, which is also enabled. So let me get an SD card. Aha. Oh, okay. So that's been reported through a different ID. Yep. Okay, so is that also listening to the same RQ mode stuff on 6? I think so, yeah. So 1. Yep. That's on the rising edge. Falling edge. Both. The interesting thing is that the hit event is different, but I guess that just means that the lid switch is special somehow, and it gets reported through a special hit event instead of a general GPIO event. Which kind of makes sense. Um, yep. I guess it just reports everything, really. That's fine, though. Okay, so that, I think, mostly concludes the GPIO reverse engineering. Still don't know, though, what that bit does. That 8. But then there was that bit at the top, which is kind of interesting. Um, okay, so this is actually really upper buffer, and this is more like pin action. I think that's pulse. That would make sense anyway. Unless it's just like an inverse bit, which it could be. It could be. It might not be pulse. That might actually be the inverse bit. Um. See that one. That one actually makes sense. Like DP to HDMI function reset. That might not be pulse. That might be just invert. So 18 is backlight power. Can I mess with that? 18 would be... That says backlight air, actually. Hold on. What about this one? Same. 19. Okay. 19 would be 13. Mm-hmm. Okay, that kills it. Okay, the backlight does flip, so that's good for testing. Yeah, that just looks like invert. Okay, so that's the invert one. What about this 80 thing? It doesn't do anything. I have an idea. Nope. No idea what that is. Yeah, pull up enable or something like that. I was wondering if there was a pull up somewhere. But then in output mode, that doesn't make any sense. Unless I set the pin mode to like it's probably weak anyway. There's a Touch ID backlight? What? The Touch ID button lights up. They learned. It apparently has 4 LEDs even. Apparently it's FPWM2. I wonder if this display SPI is actually how it's doing like the matrix backlight on these MacBook Pros. It shouldn't though. What was it described in the ADT? Oh, so Tcon is a separate SPI. There's actually a display SPI, huh? That actually kind of makes sense then, yeah. That's a low serial number for the panel. Hmm. And there's like hex encoded hex here. Yeah, there's like hex encoded hex or something. Apparently the cover glass has a serial number. Because of course. RF exposure separation distance. That sounds like fun. I wonder if this is a speaker like EQ matrix or something. Yeah, anyway, we don't know what that bit does. And I'm going to do one more check and see if it's required for enabling those two things. Let's just boot that with PCI enabled devices. Let me not break that. We got FMAC. Did we get the HCI? Yes. Also, NVMe apparently doesn't work. Um, ah, it's probably just not compiled or something. Yeah, it's just compiled. That would help. Okay, it's booting. No. Oh no, the SD host controller is there. But it doesn't work though. Well, that's interesting. Huh. Did I break that or am I missing a patch? Oh, now it works. I was just slow. Okay. Okay, it works. Not sure what's going on there. Yeah, okay. So I know enough about how GPIO works. I still have no idea what those what that bit does, but this makes sense, and it's enough to write a GPIO controller. But it is it's been a good 8 hours, so it's probably time to call it quits and get some dinner, I guess. And then continue maybe tomorrow, maybe the next day. We'll see. But this looks good because this sorts out the GPIO confusion we had. And so that sets that tells me what I need to know to write this GPIO driver. The button looked pretty easy, though I'll have to look at the notification stuff. So we'll see how that works. But it shouldn't be too bad. So yeah, thanks for watching, and I'll see you next time.